Hi, this is Andre again. Today I have some exciting news about the MicroPET and its related family members. Yes, the family has grown not only in size, as you can see here, but also in number. If you want to know more, stay tuned. If you have followed the channel, you know that I have been working on the MicroPET, a Commodore PET clone with many more features. And while the first version of the MicroPET, like that I'm showing here, only really had black and white VGA video output and no expansion capabilities, I decided to evolve that board into a bigger one to include color, more graphics features in general, like sprites, better sound capabilities, a real expansion bus, and in general more expansion capabilities overall. This evolution of the MicroPET has become a whole family of boards, and I'll be going over the details in just a minute. So the first one that I'm showing here is, not screwed in, is the Ulti-PET. This is the largest member of the family that I'm showing you here. And then we have the new MicroPET, which has become a little bit larger than the original MicroPET, and it's a direct evolution of the original MicroPET. It's much smaller, but it still does not have as many features and no expansion bus. And the third one is the Ultra CPU board, which has just the CPU technology, and it needs the PET I/O board for all the I/O that the PET has, and the bus, the Ultra Bus card. The Ultra Bus is mainly the bus I've been using since 1989, but now you can also use Apple II boards and RC2014 boards. And it also doubles as bus extender for the Ulti-PET. So what's the new stuff here? Let me get into the details. So let's get to the feature overview. If we look at the CPU and memory, we have a 65816 CPU, which runs at 17.5 MHz speed, which can be slowed down to 124 MHz. While the I/O is always running at 1 MHz, because that's going over the bus. And we have 512K of fast RAM and 512K of media RAM, which is the source for the video and the digital analog converter sound output. All variants have the same graphics capabilities, because they have the same, basically the same VGA on the board. And we have 768 by 576 RGB VGA output. So if we have an 80x25 character mode, we actually have borders. We can have up to 96 by 72 characters on the screen. The screen geometry is mostly CRTC compatible. You have the hardware cursor and then other features. But it's also mixed in features from the VDC, from the Commodore 128, and the VIC-2 from the Commodore 64. So we have sprites, we have raster interrupts, color modes, high-res, attributes, lots of stuff. Something really nice is it's ColorPET compatible. It's got a ColorPET compatible mode. So you can run software written for the ColorPET design by Steve Gray. It's got two palettes with 16 colors each. You can have 40 or 80 color modes. You can swap alternate resistors on a raster line match and much more. When we look at the sound, all of those have a stereo 8-bit digital analog converter. And if you look at the Ultra CPU, you only have other sound on the extra bus cards, like the PET I/O here, or you could have a dual SID card like this one. And then the MicroPET doesn't have really many extensions. It's got the stereo DAC but this is mixed with a beeper output and going to an analog output connector. And the Ulti-PET has all of that, plus the dual SID built in, and a mixer and a small speaker arm, so you can actually attach speakers directly. Looking at the I/O, all of them have SPI based I/O, which is flash ROM actually, real-time clock, Ethernet, Wi-Fi, networking, USB and SD card. The Ultra CPU has a lot of possibilities using the bus for my original bus with where I have lots of cards on my website, the Apple II cards and the RC2014 buses, or even the Commodore 64 extension. The MicroPET only has the PET I/O that can also work as a disk drive, and the Ulti-PET has all of that combined, plus dual SID and lots more stuff. So let's look at that in more detail. Let's have a look at the Ulti-PET board and all the I/O that's been packed on that board. So from right we have the power supply, which is actually a single 5-volt power supply. We have power switch, we have joystick ports. Joysticks are compatible with the stupid Petrix user port connector, which is where the user port is actually here. We have a 9-volt generation, which can be used for the SIDs. I haven't tested it with real SIDs. I've only tested it with, say, FPGA SID, ARM SID, and X SID, SID replacements. So there is a dual SID, as I already mentioned here. Here I have the original CSA bus, my original bus here. There's one connector on board. I think populating this one is optional. This one does make sense to use it, because this one does make sense to populate, because you can use the Ultra SID board as an expansion bus for the Ulti-PET. And then you can use the same Apple II boards, RC2014 boards, or even Commodore 64 expansion I/O boards with the Ulti-PET as well. Here is 2 connectors for SD cards for different breakout boards. This one is not produced anymore, so I'm switching to this one, where I'll probably put in a slot in the case where you can change the SD card directly. We have a reset switch, which is dearly needed on the original PET, and there is a potentiometer and some connectors for the speakers that you can connect if you want to have sound built into the case. There's the audio output, the video output, USB output, and there should be a breakout board for the network on top of the USB, which is here I have an Ethernet board, but I'm working on a Wi-Fi option as well. This one is the Commodore serial bus, and it's actually the fast version from the Commodore 128, and so you can use the 1571, 1581 disk drives. There is a tape port, which is also supplied by the 9 volts here. We have the IEEE 488 bus. So basically this here is the original Commodore PET I/O. So we have the I don't remember in which order, via Pia or whatever order that is, and then that is the original PET I/O. And there is a second VIA, second 6522 versatile interface adapter, which is used for the serial bus here. Here is a dual UART UART serial communications interface adapter, which goes to an RS-232 interface here, which is using the MAX232 drivers. There's actually the diag switch here, where you can enter the monitor in the, I think, basic 2 and basic 4 versions. If you press that button, it's actually pulling down a pin on the user port, and the system boots into the monitor and not into the basic. So here's the dual SID. Here, this is actually very nice. So if you use a modern keyboard, which I recommend, because my take is don't ever use any or take anything out of a working PET to build the micro PET. So you can use those keyboards by Steve Gray. I have the keycaps on my web page as well, but there are no locking keys like you need for the shift lock. So there is a small circuit here that actually does the shift lock circuit, and if you press the shift lock key for 3 seconds, it also resets the whole machine, which is quite nice. And when I presented it at the some of the events, that was a really nice feature. Just hold down the shift lock key for a moment and the system reboots. So these 3 connectors here, they will move a bit, but they will be there in the next one as well. So one is a 5-volt SPI connector according to the SPI 10 standard of 6502.org, and you can use the SPI mode here by setting a jumper. This is 3.3 volt SPI interface, also again SPI 10 by 6502.org, and this is directly coming from the FPGA, where you can set the mode via a register. And here we have an Olimex UX connector, which has the same SPI from here, which has the second RS-232 from this dual UART, and an I2C bus as well. So you can use all the Olimex UX extensions as well. I think that concludes it. So this really is kind of my dream PET clone, and yeah, I hope you like it. Let's have a look at the ROM support that we have, and what you see when you boot up the machine. So when you switch on the machine, you see this boot menu, and you can see you can select the different models and basics. You can even select an 8296 model, which has 128K of RAM and 80 column and with basic 4. You have extended or patch ROMs, which are the default, but if you use the left shift, you can use the original ROM. Typically, or by default, it's using the Commodore PET N type keyboard, but you can also use the Commodore 64 keyboard for the basic 4 machines, because that's an option that Steve Gray has put into the editor ROMs. You can also use the a USB keyboard instead of the PET keyboard, and then it's automatically supported in the basic 4 variants. I may be looking into adding USB keyboard support and SD card support for the other basics too. Speaking of SD cards, yeah, it's already in the ROM, and yeah, you can just use it as Unit 8 if the SD card is inserted into the machine. So let's have a look at how fast the machine actually is. So I'm going into the unmodified ROMs, and I'm loading the benchmark program. This was originally written for the micro-PET, and what it does is it calculates from the 60 Hertz screen refresh how many cycles the CPU has for one screen, and then for 60 Hertz, and then therefore it can calculate the megahertz or the CPU speed from that, and also the CPU speed. So this is the timer, and then it also compares that to how fast the CPU is compared to the timers. So then we can run various tests. We can see the CPU speed test. We see the system is always running in 1 megahertz, and the system here means basically the VIA timers, but the CPU is running up to 16.6 megahertz. Maybe some calculation inaccuracy, maybe, but it should be 17.5. Now, if we go to fast RAM, we see that when we take 4 megahertz, and then we have the try to change some of the screen functions, we see it doesn't have any effects. So, but that's in fast RAM, and then we have the video RAM. The same test is running in the video RAM, and we see it only gets up to 7.3 megahertz CPU, because the video output is taking a lot of cycles from the memory. I have to adjust the benchmark because this is not correct, because I changed the configuration settings that the benchmark does not do that yet. So I can also show you the burn-in test of the machine, and I'm going to use the 8296 version, because that shows you the auto detection of the test. So you can see here it's running at 17 megahertz. It's detected the 816 CPU. It's testing the standard PET IO. You see the something, because I patched the kernel, and so there is something. It's not passing here, but everything else passes. You actually have to disconnect the IEEE 488. So I loaded this from the SD card. And then you can see you have the 8296 memory management tests, and then you have the Ulti-PET or micro-PET tests as well. And you can see here AT&A, you can actually use the machine either on the IEEE 488 as well as on the IEC bus as a disk drive for other machines, given that you run the right software for it. So that test here is included. But because the system has memory mapping built in of the lower 32K, we can actually run multiple machines at the same time. Not exactly at the same time, but well, kind of. So if you use left shift and right shift and reverse to switch, you see we suddenly have the reset beep, and we get another machine here, and then we have left shift, right shift and reverse, and we have a third machine here, left shift, right shift and reverse. We have a fourth machine here. Okay, that doesn't work because that's unmodified drums. We have that here, and then left shift, right shift, reverse. We are back to the first one, and so on. We can switch through 4 instances of our PET. Isn't that cool? So I connected the USB keyboard to the Ulti-PET, to the back of the PET here under the Ethernet connection. And if I use the 8 key, and I actually use the Shift 8 key. I'm getting to the original one, and then you can actually see you can use the USB keyboard with the micro-PET and the Ulti-PET and the Ultra CPU, and run it without an original keyboard actually. So let me show you some graphics demo. Here you see a small demo that I tried to write, but my demo capabilities are not that good. You can see the different color modes. You probably don't see it on the screen, but only every other raster line is being drawn to give that kind of cozy CRT feeling. But you can also draw every raster line, and then you get interlace mode. You can see it's switching palettes. We have the sprites, we have high-res mode. We have a redefinable character set, which is all in RAM anyway, and we can use the whole screen for graphics. So yeah, lots of features in the graphics area that you can use. So I have now connected a loudspeaker to the back of the machine using the audio output and drawing power from the USB cable. And let's see what the audio can do. And this is actually now coming mostly from the speaker and not from the beeper that is actually built into the machine. So maybe you can see the blinking here of the FPGA SID, which is shows it's being used as a single SID right now, and then you hear some of Rob Hubbard's music. So that totally works. But you can also have duck output. And maybe you recognize the beginning of the song as being loaded from disk right now. Did you hear that? Write me in the comments down below if you noticed what song that was. There already are a couple of games that support the color PET, and you can run them on this machine as well. So let's have a look. Did I mention there's a wedge built-in if you use the modified ROMs? Okay. So you can see here, this is the Grid Runner game. Press fire to begin, which is A. Oh, that was quick. So I'm not really good in that game, but you can see even with beeper you can make a lot of nice interesting sounds and it's actually using the Ulti-PET color mode, which is quite nice. Now let me show you the joystick support. So I have plugged in a joystick into the first port here, and now I'm going to run a game that uses joysticks. It's actually a new game. I'm not that good playing games anymore, I guess. Especially not if I have to look at the recording screen at the same time and see if it all works out. So this was my presentation on the Ulti-PET, the Micro-PET, and the Ultra CPU with the bus system that you can use. And I hope you like it. You've seen all the features. So you may ask yourself, how do you get all that stuff? So everything I've shown today is open source. You can find everything on GitHub. There is the link in the description down below. There's one master repository that pulls in about 10 other repositories for the firmware, for the FPGA programming, for all the boards. All the boards have Gerber files and bill of materials with part numbers for Mauser. I know it's not the cheapest shop in town, but it's a one-stop shop for me, so it's the most convenient for me. And you can use that, so you can easily build them yourself. The only thing is you have to be able to solder those fine SMD pitch ICs. So the next step forwards will be I'm doing a revision of the Ulti-PET, because there are some placement issues with the connectors and a couple of minor bugs on the schematics, but this should be basically the final revision 1.2, which is in the works right now. The other two boards use an SD card breakout adapter that's not produced anymore, but you can still use them with other adapters with some patch cables. So that's not high on the priority list. I'm working on the 3D printed case. I'm working on better ROM menu and ROM options to include the serial IAC connectivity in the ROM itself, which it is currently not. Yeah, so work is going on. I hope I've given you a good introduction to the machines and to their features and the potential they have, and hope you like it, and see you next time. Thanks for watching.